Hello community, welcome! Today we're going to talk about SetFit, few-shot learning with SBERT. Now, there is a new sentence transformer fine-tuning methodology for an efficient and prompt-free framework for few-shot fine-tuning on sentence transformers. In my last video, I showed you in detail the theory behind it. Now you know we have two steps to code. The first, we have to find a small number of text pairs, a full number of examples per class, and we have to take a pre-trained sentence transformer, an SBERT model, and then we fine-tune those model. And the resulting model is then used to generate rich text embeddings with we take and we train a classification head on top of it. And this is it. We achieved a text classification task. Beautiful. We have two advantages. We do not need a prompt like in GPT-3 in zero-shot or one-shot or few-shot learning. And we have orders of magnitude less parameters that we need for the training cycle. So we will have here a look at about 8 examples per class, 16 examples per class. And I show you a data set where you have about 50 examples per class. And let's have a look at it. Now, of course, important, the license information. If you, again, have not seen the last video, here is the archive preprint. And of course, they have on GitHub and Hugging Face a specific repository. Beautifully. Just that you know, although it is just as you can see here from September 2022, we on Hugging Face have already 109 SetFit models and about 150 SetFit datasets. Just to make this available to you, here we go, Hugging Face SetFit. Of course, we are still in research, so you have to be careful about this. But you see, we have 109 models. My goodness, 109 models. And with the datasets, we have 150 datasets people uploaded. If you can see, September 8. Go immersions and all the different data sets and model. And so I would say, let's just jump to it. At first, the easiest example we can think of, two classes. Text classification, where we have a class 0 and a class 1. This is it. Good, bad, positive, negative, whatever. All credits go to the SetFit team, see also the license information. And at the very first beginning, we use a very simple data set. And this is SST2. This is the Stanford sentiment tree bank. We have here about 12,000 single sentences, and they extracted about 215,000 phrases from those. And each 3 human judges annotated this. So if you want to have a look at this, nothing easier than that. Here in Hugging Face datasets, we have SST2. You have here the dataset preview. And if you look at this, let's start from the beginning. You have here sentences. Hide new segregation from the parental units is labeled as 0, negative. And then we demonstrate that the director of such a Hollywood blockbuster, yes, is labeled 1, and this is a positive connotation. Beautiful. This is it. If you want to know the distribution, we have the data split. Training, we have 67,000 samples. Validation set is only 872, and the test data set is 1,821. Those are the number of examples for training, validation, and test. And this is all available for us. We just have to download it. So here we go. Well, first step, pip install SetFit. Great. Let's do this. Oh, we need a GPU. Oh, heaven's sake, we need a GPU. Hold on a sec, we need a GPU. I'm so sorry, I have to take away your GPU. I need a GPU just for demonstration purposes, but I promise I switch it off immediately after done this. Yes, please delete the runtime. I'm so sorry. So here we go. SetFit.3. Beautiful requirement. Yes. Let's see. Okay. Oh, dependencies. Sentence transformers. Beautiful. datasets, Hugging Face Hub, multi-process responsive dataset. Beautiful. So what we do now, we load our dataset from the Hugging Face Hub. And we load exactly what I just showed you as ST2. This is our dataset. And then we're going to have a look at the dataset if it is already correct. And I recommend to you always have a visual look, always inspect it visually, just to be sure that everything is working out fine. So, oh God, we have a slow connectivity today. 94%, 100%, training split, yes, done, yes. So here we go. We have our training dataset, we have our validation dataset, and we have our test dataset. And this is the numbers I just showed you before, so seems everything is working out fine. So, ladies and gentlemen, and here we go. We have a few shot learning regime, so we say, okay, the number of samples we provide to the system per class is, now let's start with something reasonable, is 16. And the number of classes is 2. 0, 1, good, bad, positive, negative. We have number of classes 2. And then we take our training data set with this specific regime. So 16 times 2, you're not gonna believe it, 32. Beautiful. And then we take also the validation data set because we want to evaluate the performance of our model. And so all we have to do, and you know this, as I showed you in my last video, we take a sentence transformer, a pre-trained model specific for your task, and we have here the paraphrase MPNet, sentence transformer, our SBERT model, and we just load it from pre-trained. Beautiful. Now, next step we have to do is that there are two things created for us if you want. And the first thing is a trainer, a SetFit trainer module. And step by step. That's the license info. Yes, yes, yes. Our trainer model. Now we have, of course, our SBERT model, the training data set, the evaluation data set during the training. Then we have a cosine similarity loss, very easy. Metric is accuracy. The batch size is 16. Number of iterations, 16 times 2. Batch size is 32. Number of iteration, yeah, come on, let's do 60 at least. Number of epochs, I guess we have to go for 3, yeah? I mean, come on. Because we want to have an evaluation and we don't want to stick at 60%. So let's do a little bit more. So how long does it take for us to train this model? Oh, 1 minute. So we have 3 minutes, and altogether. That would be great. So what we have? We have a training batch size of 32. We have an optimization step of 120. We have the number of epochs of 3 and the number of example is defined. Beautiful. So this is it more or less. Let the system train itself. And then when we come out of the training loop, we evaluate our training model, the model performance using our evaluate methodology. And you will get simply a numeric value. Now, if you have seen already, where is it? Here, number of models. A lot of people have, this is from SetFit, 109 models. So if you have a specific data set and you train a specific SBERT model, where is it? Here. Whatever model you choose, you can choose, I think, almost all sentence transformer model on Hugging Face. You get a specific model and you can push this model to the publicly available hub with your credentials and you can download it from the hub for running your inference task. Now, beautifully, I don't have to show you this. This is just for upload and download. We're interested in the performance, of course. Iteration 1, iteration 2, and iteration 3 is already up and running. And if we have our model trained, then comes the moment you've been waiting for, inference. And we provide 2 sentences to our model. I love the Spider-Man movie. Okay. maybe you would say this is a positive connotation. And this is the worst something. Now you would say this is maybe a negative connotation. And we will see with this highly sophisticated example what our model will predict as the sentiment of this sentence, where we only have, and this is important, provided 16 samples to learn, to train for the model. Now, normally, if you have an SBERT model or BERT and you run this, you have thousands of samples to be able to train. And we have just 16. Maybe we run this later off with just 8. And let's see about the evaluation. But for the moment, hey, train is finished. Let's see what our evaluation tells us. I hope we're above 70%. Let's have a look. Oh yeah, and then we run, of course, the prediction. We don't have to wait. Hey, we have an accuracy of 87%. This is not bad. Come on, this is not bad. And yes, oh yeah, of course. Yes, sometimes I am not thinking at all. We have, so let's check just to be sure. What is positive? 0 is a negative connotation. So we got back. 0 is a negative connotation. So 1 is a positive connotation. I love this movie, and we have a positive connotation. The second element in the list is worst something is a negative connotation. Congratulations, it works. And our accuracy is 87%. Just with 16, here we go, samples. Now, what about we say, okay, let's halve the number of samples. I mean, this is critically low. Be careful, but just for demonstration purposes. Let's see what comes out of this. We do not have to change this. We do not have to change this at all. Number of iteration. Yeah, we stick with the same number of epochs and number of iteration. Oh yeah, here we go. Let's train it, let's evaluate it. If we halve the number of examples per class, so this is critically low. Oh, it's much faster. Well, of course. Here we go. What about our resources? Should be no problem at all. Everything is beautiful, for up and running just fine. We have system RAM, GPU RAM. Oh, such beauty. So 1, 2, 3, 1, 2, 3. Now, next step, let's have a look, is of course multi-class, multi-label data sets. And what we have to do, programmers have been so amazing. You just have, when you load your model, you set from pre-trained as always, then you have the model, the SBERT model from Hugging Face, and then the only parameter you have to set is a multi-target strategy. And from multi-target strategy, you have 3 options. And this tells it, hey, we have a multi-label. So the first one is one versus the rest. Then you have multi-output and a classifier chain. If you have your specific data set, you know what you're looking for, but just to make sure, those are the 3 options currently supported. And let's see where we are. An accuracy of 79%. This is not bad at all. We have a number of iterations, 60. Yeah, of course, if we reduce it to 20 and the number of epochs to 1, we got closer to almost something like 50. But you see that this is a really good performance model if you have a low number of examples per class. So finally, now we enter multi-label data sets. Beautiful. So what we take more or less the same paraphrase MPNet Sentence Transformer SBERT model from Hugging Face, and we load a specific data set for multi-class. This is the Atos data set. We have to do it. Not just talk about it, maybe do it. We have our NumPy and we have our training data set. Number of samples now 8. This is really low. I mean, you can try it out yourself, go with whatever you feel comfortable. And then we just encode it, yes. And the training data set, the evaluation data set, you are familiar with this. And here we go now with the fine-tuning of our multi-label SetFit model. And as I showed you, it is the same as before. We just have now a new parameter, multi-target strategy. And we go one versus the rest. And as you can see now, I call this model 2, not to mix it up. Oh yeah, we get an error message. No, it's just an indication. Not found on the hub, initializing a classification ad. Yes, with random weights, this is exactly what we want. You should train this model on a downstream task. Well, you're not gonna believe it. Here is our trainer already set up for us. Thank you for this comment, important. Model 2, training dataset, evaluation dataset, similarity loss, batch size 16. Number of epochs. I mean, one is yeah, iterations, multi. I go with 80. I mean, whatever you choose. You can really play around with this system if you want to have a look. And let's train it and let's see our metric. So. Oh, wow, this is something from the training data set. Okay, maybe I could choose some more intelligent sentences, but whatever there is. So here we go. Number of examples, 30,000. The number of epochs is 3. Total optimization step, close to 1,000. Training batch size 32. Oh, great. This takes about quarter of an hour. So we're in for about an hour of training time. You see our GPU RAM is up to the critical red. Okay. Let's make it a little bit bigger. Yeah, doesn't change at all. Okay, GPU RAM maximum. And I would say I will be back with you in about 45 minutes. See you then. And while I'm still waiting now on iteration number 3, I just thought about, hey, wait a second, how can I make this visibly? You know, here the multi-label classification hat from scikit-learn. How can I have a very simple explanation in this video? I mean, if you go to scikit-learn with the one versus the rest classifier, it tells you, yes, we can do this, and you can also use this for multi-label classification, and the way this is done, and yeah, you have an example. This is all nice and beautiful, but I am more or less looking for a very easy example for you if you're not familiar with this. And I found this one here, and this is in Geeks for Geeks. So here we have this one versus the rest methodology. And many popular classification algorithms were designed natively for a binary classification problems. Now, you know, logistic regression, SVM, perceptron. And a lot of methods cannot directly be used for multiclass. So if you have, for example, you have the task of classifying 3 different types of fruit, a banana, an orange, and an apple. Now, this is clearly a multi-class classification problem because we have 3 classes, né? But we can, if you want, slice it up. There are 3 classes, and the one versus the rest methodology will break it down into 3 binary classification problems. At first, it's banana against the rest of the world, and orange against the rest of the world, and apple against the rest of the world. So we have now 3 binary classification problems. A major downside is many models have to be created. Yes. But it's useful for datasets have a small number of classes where we would like to use SVM or LR. Okay, so yeah, I think this is a nice example. So you will have 1 against the rest of the world. So you have more or less a binary classification problem. And of course, then if you go for a scikit-learn multi-output classifier, then you have the multi-target classification. You have the parameters, and you have here a simple example if you want to follow it along. Also, if you want to learn a little bit. So I think this is it for this particular case of one versus the rest. And multi-output, yeah, classifier chain, you can look up yourself, no problem. And then what I thought about the training data sets. As I told you, just to have to go here that I don't miss it, that there are a lot of training data set for SetFit already available on Hugging Face. So I'm here on Hugging Face, I'm here on SetFit, and there's this Go Emotion data set. You have here the file, you have the JSON, the test training and the validation data set. You can download it, no problem. But I thought, what is it? I'm not familiar with Go_emotion. So I had a look at this, and I mean, unbelievable. Look at this. You have a text string, a sentence or part of a sentence. Here, first sentence. My favorite food is anything I don't have to cook myself. Beautiful. So I get it. This is the text string. And then, and this is the funny part here, I have emotional quantifications. Admiration, amusement, anger, approval, caring, confusion. My goodness. But what is it here, for example? I wouldn't know how to classify this sentence. So let's look where there's a 1, because almost everything is 0. Okay, so neutral. This is a neutral statement. Okay. My favorite food is anything I don't have to cook myself. I would say positive because I have the same habit, but whatever. No? So just to give you an idea, hello everyone, I'm from Toronto, can call and visit in person if needed. So what is this here? Neutral, also neutral. And nothing else? Of embarrassment, excitement, fear, gratitude, nothing else? Okay, so if you use those data set, I mean it's okay for training, but watch out if it is really the appropriate data set, the validation, the test, and the training data set for you. But nevertheless, I'm thinking it is very interesting. Yeah? If you go with those training data sets. You see here, I just picked the first Go Emotion from September 8. SetFit tweet evaluation stance, abortion. Okay, this is America. Amazon, massive intent. Okay, no idea what this is. 150 data sets. So amazing. If you look for data sets, maybe you will find it. Oh, wow, massive Amazon. I think this is quite a lot of Amazon. Yeah. Oh yeah, oh, this is our beautiful data sets. Yes, here we go. Oops, where is it? The clue. This is a port of the official data set on Hub, matched version. That the premise and hypothesis columns have been renamed. Okay, to text 1 and text 2 respectively. Also, the test split is not labeled. The label columns are always -1. Neutral entailment. We had this when I showed you how to create your own dataset. Okay, interesting. So there are a lot of interesting data. Just waiting for iteration 3, number of epochs, size 3 to finish. So if you want to learn a little bit more about the different headers we use here, Scikit-learn is always an excellent place to get more information about it. And of course, I already showed you, this is the publication from September 22, 2022, about efficient future learning without prompts. If you want to read this paper, it is really, really interesting because they compare it with different methods, with this pattern and methods and AdaPad and what was it, T0? No, what was it? Yeah. And they show you here our 2 steps that I showed you that we do now code ourselves. We have the fine tuning of our sentence transformer, and then we do the classification. The training of the classification head. My goodness, language is difficult for me today. And yes. Oh yeah, there's the RAF data set. Yes, interesting. Yes. Raft benchmark. Have a look at the Raft benchmark. If you want to see 50 examples per class, maybe you want to train it over there. T-view, here we go. Experimental setup, the results. Fine-tune, methodology, multilingual, you can go. Yeah, definitely, whatever you have. You have a lot of SBERT models, multilingual. So if you want to run your multilingual experiments for text classification, this is one of the best ways to do it, because there's so much SBERT on it. Computational costs should be rather minimum. Conclusion, SetFit, yeah, TPU. Much faster inference and training requires a smaller base model to be performant, not requiring external compute. Not subject to the instability and inconvenience of prompt engineering. Oh yeah, this is really nice. So, authors saying Hugging Face Incorporated and Intel Incorporated for providing computing resources, and the German Federal Ministry of Education and Research, and the Hessen Ministry of Science and Arts. Gee, wow, interesting where this research originated from. And yes, you guessed it, we still have 4 minutes to go. So what else there is? Yeah, we just evaluated, and then, yeah, if this will be part of the next video, because I think this video is already long enough, we have then, and we follow the textbook. There's nothing critical. This is easy, follow along the flow of SetFit, the hyperparameter optimization. They have a very nice notebook you can download, you can follow yourself. It will be part of the next video where I show you how to optimize the training of your system with hyperparameter optimization. This is a routine. They do some self-optimization. First run, it was really interesting, and the result is absolutely reasonable, but this will be part of the next video. So I will see you in 3 minutes and 18 seconds. And we are back, and iteration 3 is finished. We're gonna evaluate now. Oh, just 55%. Now, this is not that you say famous, but I just put here another sentence. I'm interested. Is policy based on scientific facts or emotional polarization? I think this is interesting. And let's see what it says in don't eat pork. Is this a religion? A lipstick suitable for people with dark skin is race, sexual orientation. Is policy based on scientific facts? Is disability? Now, 55% of all examples in all 8 labels correct is not bad, but we need to do better. Therefore, in the next video, I will show you how to optimize the hyperparameter tuning for our model to achieve better results. What parameter we have to optimize? The learning rate, the batch size, the number of epochs, the number of iteration, the maximum number of iteration, or maybe it is the solver itself. All this will be part of my next video. I hope you enjoyed this one, and I see you in the next one.